Hello everyone, and thank you for attending today's webinar for Network Project Modeling and Management, also known as NetPM. NetPM is a private or public cloud-based tool designed to help synchronize the work of a single project across various ETAP workstations, or ETAP App devices. In this presentation, we will be exploring the ways in which the capabilities of NetPM can be used to further improve design efficiency and drastically shorten project delivery times. Let's get started. A quick overview. First, we'll need to understand what is NetPM, what are the components that make up a NetPM environment, and how exactly does data flow through it. We'll then see how using NetPM can positively impact the standard project lifecycle by alleviating the struggles involved with sequential workflow and opposing targets. And finally, we will work through an example where we'll see a manager and multiple team members concurrently collaborating on the same project. Along the way, we'll elaborate on key features and added benefits that come with NetPM, such as what can sync, data history and reversion, auto recovery, and server administrative tools. What is NetPM? NetPM is a web application that can be deployed to a private on-premises server, self-hosted, or a cloud service of your choice. Note that ETAP itself does not host NetPM. Data privacy and cybersecurity is managed by your IT. For a networked environment, project managers can upload any given password-protected project to NetPM for other registered client users to download. The changes made to each project are logged and passed through NetPM back to the original primary project. These modifications can either be automatically synchronized or individually reviewed and approved by the project manager. Additionally, NetPM can also communicate with both ETAP App, our field data collection and validation tablet application, as well as eProtect, our centralized asset management and fault analysis system. We encourage you to also view these webinars to learn more about these features. With a networked NetPM environment, users from various locations can connect and collaborate via private intranet or public internet connections. This alleviates the need to manually maintain various copies of a single project file. It also minimizes the time spent passing multiple versions of files back and forth at each stage of the project's lifecycle. With both automatic and on-demand synchronization methods available, NetPM gives the project manager tools for reviewing, approving, or rejecting proposed modifications. Especially considering today's global shift to many employees working from home, cloud-based synchronization and accessibility has never been more important. Traditionally, without NetPM, various teams need to sequentially pass files along at each stage of the project. In some cases, projects can loop back several times for additional adjustments based on recent changes, easily leading to deadline delays. This manual process wastes time as it keeps our teams in a constant state of hurry up and wait. Note that since the organization is not standardized, it can be accident-prone and requires careful coordination to avoid sending incomplete, outdated, or mislabeled files. The goals of some studies can pull the project in different directions. Engineers often must wait till one team is done before another can finalize their work. For example, when we consider impedance in load flow versus short circuit. For load flow, increasing impedance effectively increases voltage drop. However, in short circuit, we may want to decrease impedance to make it more conservative. With NetPM, what-if scenarios can instantly be submitted for approval and validation. Others can immediately see and take these changes into account when moving forward with their work. This is how NetPM drastically improves efficiency and shortens project completion times. As the name suggests, NetPM was primarily intended for networking ETAP projects together. To do this, the incremental changes to each project must be logged and managed in the NetPM server. Conveniently, this log can also be leveraged for standalone or self-hosted applications to help clarify modifications that were previously made to the project. For self-hosted environments, NetPM can simply be installed locally on the same PC running ETAP. The incremental changes for each uploaded project are then maintained on the local machine. This change history is built into NetPM, so it's accessible for both networked and self-hosted environments. The log captures changes to your ETAP project dimensions, including diagram modifications, study cases, configurations, project settings, alterations to either base or revision data. As properties are modified throughout the evolution of the project, the Revert Data feature lets you quickly glimpse and jump back to prior data versions if required. Should the project ever unintentionally close without saving, the recovery feature automatically reprocesses the log changes from NetPM to get you right back on track. Administrative tools let the designated NetPM server admin oversee and manage the project's publications and uploads stored on the NetPM server. Now let's take a look at NetPM in action. Here we have a project set up to automatically synchronize changes between the project manager on the left and engineer 1 on the right. Using AutoBuild, engineer 1 will go ahead and expand this bus and add a few components. Immediately, these changes are reflected in the project manager's project. We can utilize tools existing in ETAP that speed up the creation of the one-line diagrams, such as AutoBuild, templates, and copy-paste data. To do this, we can select a group of components, then right-click and shift-click the property option in order to copy the data of that particular anchor element to others that were selected. You can also use Shift-C to copy the anchor element's properties to others. With this information immediately available, the manager can continue his work without having to wait for the project to be fully submitted. Adjustments that the manager continues to make to the project are also immediately reflected in the client's project. This way, engineers can run their analyses without any delay. Let's now take a look at how ETAP App can also be incorporated into this NetPM environment. Let's start by switching to Edit mode, then selecting all the components within this subnetwork. Now we'll launch the DataX Manager, or ETAP App Manager, and create a new publication to be sent to Engineer 3. At this point, we can specify an extension and description to help identify this publication on the mobile device. From any iPad, Android, or Windows tablet, we can now launch the ETAP app and go to the Projects page to enter the NetPM URL, Engineer 3's login credentials, and log in. Here we find the publication that we just created. We can download it and open it in ETAP app. We can open up the subnetwork that was sent to ETAP app, and let's try to identify the components on the drawing by enabling the annotation IDs from settings so that we can locate a particular transformer. Let's try to locate TR5 transformer. And with this transformer, let's go ahead and attach an image. If we were in the actual field, we could capture the image, but since we're working from a desktop at this point, we're just going to go ahead and attach. Let's attach a nameplate. And let's go ahead and send this back to ETAP. So go back to Projects. Now back over at ETAP, on the ETAP Project Manager's project, we're going to check our Imports tab, refresh this guy, and we'll see the uploaded project that directly came from the ETAP app application. Let's go ahead and merge this now into our project. And the DataX Manager will then bring up the Merge and Sync window, where we can specify which modifications we want to accept. So let's accept everything for now, merge all. Once the merge is complete, we're going to go ahead and jump back to that data center and locate TR15. And here we have the transformer with the nameplate data attached as a hyperlink image, directly submitted to ETAP. We can now take a look at the Engineer 1's project and observe that the same information has now also been submitted to Engineer 1 automatically. In addition to one-line modifications that can be submitted between the projects, we can also observe other dimensions of ETAP that can be synchronized, such as our configurations and study cases. So here I'm going to expand the system manager in both projects so we can just observe the components that already exist in both projects. Let's take, for example, first the configurations. Let's say Engineer 1 decides to create an additional configuration to this project. You can go ahead and go into their configuration manager, create a copy of tie-closed configuration, call it config. And immediately the configuration is created also in the manager's project. Modifications to those configurations are seamlessly also synchronized. Let's take, for example, the configuration we just created, config2. Within this configuration, let's switch also to config2. And let us change the status of a particular device. As you can see, the configuration status is immediately synchronized between the projects. Not only can we create configurations, we can also delete them and have them synchronized between the ETAPs. So let's set the Engineer 1 project to normal, and then in the manager's project, we will go ahead and delete configuration 2 that we just created. As you can see, adding, deleting, or modifying configs is completely synchronized. Next, let's consider the scenario that the manager wants to review changes prior to having them merged into the project. For this, let us actually first maximize the manager's project, and let us go ahead and launch the NetPM web interface. Upon doing this from the manager's project, you will actually be given two NetPM queues. One is for the local queue of changes that are stored locally on the PC, and the other is for the NetPM server's queue. We'll notice that in either of these pages, you'll have two tabs, one for download and one for upload. Download represents all the changes that are coming into the queue, and upload represents all the changes going out. So for the NetPM server, the download queue represents all the changes coming in from all of the client ETAP users. You'll see a list of, if you had multiple engineers working on this project, you'd have a list of all the different engineers and all their submissions to the project manager. Similarly, the upload tab will have all of the modifications generated by the project manager, whether those be the ones that the project manager created themselves or the ones that the project manager has approved from others and is resubmitting to the rest of the team. In the NetPM queue, you'll see in the upper left-hand side, right below the upload and download tab, you'll see an auto or on-demand setting. Now this is the way that you'll switch between automatic synchronization and manual synchronization. Upon switching this toggle from auto to on-demand, we will then have a few options that become available for the project manager. At this point, the project manager will be allowed to either approve, hold, reject, or review any of the given proposed changes that show up in the queue. At this moment, we don't have any proposed changes, so let's generate some. Let's say that Engineer 1 first adds a few components, such as maybe adding a cable using AutoBuild. Let's say they also make a modification to a transformer, the transformer's rating perhaps. Let's again launch Configuration Manager to create a copy of a configuration. And lastly, let's go into our study cases. Let's go ahead and switch over to load flow and generate a new study case for load flow. F1, as well as a new study case for short circuit, SC3. Lastly, let's go ahead and modify a few project settings. So let's go to Project Settings. Let's adjust some of the names of our loading and generation categories. Let's say, for example, generation design. And let's take a look at what effect this had in the project manager's NetPM queue. As we can see, there are several markers now that indicate proposed changes that came from Engineer 1 and are now sitting waiting to be reviewed and approved by the project manager. We can see the study cases that we created, the components that we modified, as well as the configurations that were created, and the project settings that were modified. The manager can go in and individually review the changes proposed here by looking at the details. Let's take a look at the branch category and observe the differences between the proposed data from Engineer 1 compared to what's existing in the manager's queue, project. So as you recall, we modified already the MVA value for this transformer, and it has not yet been processed into the manager's queue. The manager can choose to either approve this, hold it, review it, or reject it. Let's see what happens if we first set it to on hold or review. This is simply a new state that does not process the change into the manager project, and it also does not send any reversion back to the client. Conversely, if we were to select reject, the change is marked as rejected, no longer highlighted in red, and in the client's project, we see that the change has indeed been rejected, and the rating has been reverted to its previous state. Let's again take a look at what happens if we approve changes. This time, let's see what happens if we approve the proposed creation of the study cases. So in our study case section of the system manager, we can take a look at load flow, and back in our NetPM queue, we can switch over to the load flow study case, select the proposed change, and this time hit approve. Once approved, the change becomes processed and is submitted into the project. Let's also take a look real quick at all the different features nested into this NetPM queue. So we already took a look at briefly the filters on the left-hand side that are able to show us specifically component changes, study case changes, three-dimensional database changes, and project settings. In addition to those filterings, you can actually also group the columns within the table itself. So let's say, for example, you had changes happening amongst several different engineers. You can actually select to show the changes per engineer by dragging the column into the group section, the group filtering section at the top. You can even choose to filter by date. So let's say these changes are happening over the course of several days, weeks, or months. Greatly help to kind of filter through the information to show you exactly what you're looking for. In addition, you'll also notice that there are some options to help you more quickly process the messages that you have in front of you. First of all, you can choose to expand the total number of items listed in the page. You can choose to increase the maximum number of items allowed in the list. So you can create a max here to show the most recent set of messages. Another great thing that is available to you in this view is the ability to toggle back to auto mode and actually automatically process any unprocessed changes. So let's say, as the project manager, you've reviewed all you can and everything else looks good. You don't need to go through and click every single message. You just want to go ahead and switch back to auto, make everything in sync with all the other projects, and not have to manually do any of the processing. You can use this option in the middle, process all, and switch to auto. Upon doing so, all of the proposed changes that have not yet been reviewed will automatically be processed and the projects will become fully synchronized. Let's now take a look at a few of the other built-in features that come with NetPM that are also available for the self-hosted scenario. So the queue of changes that we saw previously in the NetPM server is also available within the project itself. So the feature called Revert Data, when you right-click any component, allows you to key into all the incremental changes that have been made to the properties of that particular element. So you can quickly go back to previous states, different versions of data for that given element, and you can even compare it to your current data or your baseline data, the original data from the project. So let's say we wanted to revert this transformer to the rating of 5 MVA. It's going to ask if you want, are you sure you want to do so? And we can immediately see the change in the project itself. Let's come back to Engineer 1's project. And this time, let's actually simulate a situation in which maybe a large amount of information or elements have been added to the project, and a lot of work has gone in, and the engineers spent a lot of time to do this. However, he unfortunately forgot to save the project. And at some point, perhaps there is a power outage in which he is unable to save the project before the system is shut down. So let's see how NetPM can actually be used. So right here, let's simulate first the unexpected shutdown, and let's go back to relaunch the same project. Again, the changes were not saved. And we'll see as the project is reopening, you'll have a dialog indicating a recovery taking place. And what that is ETAP communicating with NetPM, understanding what the data is in the project and what modifications have been processed on the NetPM server. And those processed changes that don't appear in the project yet are going to be reprocessed back into the project again. And now we can jump back to that subnetwork, data center subnetwork, and we'll see that the elements that we added prior to the unexpected shutdown are there, and NetPM is going through and correcting all the connections and locations of the components according to what it has saved on NetPM server. Let's now consider the server administrator feature. So first off, we need to be aware of the NetPM URL, which can be found under project information. This is the address that the project has been registered to. We can copy this and open it up in a web browser with access to that NetPM server, and we'll be welcomed with a NetPM server administrator login page. The server administrator credentials are defined during installation of NetPM or can later be reconfigured through NetPM console. Upon logging in to this page, you'll see 3 different tabs, the first of which is for license, where you have the NetPM's machine ID, which needs to be sent to our sales team in order to be given the update license code, which will then generate the amount of active projects allowed for the NetPM server. From the projects page, we see a full list of all the projects that are registered and uploaded to this particular NetPM. You can filter and sort the information to quickly identify what you're looking for. You can even group the columns, similar to the NetPM queue of changes. You'll notice that there are statuses given to each project: active, inactive, or archived. Only active projects count against the allowed project count. The full list of projects displayed can also be exported to Excel. You can also select individual or multiple items from this list to either delete, archive, deactivate, or activate them. When a project is active, communication between primary and client ETAP machines is enabled, meaning the queue of changes can be set to either auto or on-demand, and changes can be processed between them. When a project is deactivated or the status is set to inactive, That means the communication between primary and client ETAP machines is temporarily blocked. This means that NetPM queues for these projects will be set to a disabled on-demand state. Proposed changes will accumulate locally until the administrator reactivates the project. Inactive projects do not count towards the allowed NetPM project limit. Finally, to account for the situation in which a project is completely done and communication needs to permanently be disabled, we have the archive status. Projects in this status can still be downloaded from NetPM, however, all the downloaded projects will no longer be connected to one another. Archive projects do not count towards the project limit, and they cannot be reactivated. Should you need to, you can always delete projects to clean up the queue and remove them completely from the NetPM server. We can use the Publications page to see a full list of all of the exports and imports to the ETAP app users on this NetPM server. Similar to the Projects page, you can filter and sort and even group all of the information to quickly find what you're looking for. You can see who these publications are addressed to, and if required, you can clean up any older publications that no longer need to be on the server, or you can export this list to Excel. Let's now take a step back and review the key takeaways. The ability to network and synchronize incremental changes helps improve the project's design validation through seamless collaboration. This naturally boosts project productivity as team members no longer need to sequentially pass project files along at each stage. The built-in log of modifications provides an accessible history of data changes that can be reverted to or recovered from. Server-level administrative tools allow for quick cleanup and management of projects and mobile publications on the network. In short, NetPM is a powerful tool with many benefits for both large teams and individual engineers. This concludes our presentation. We hope to also see you at the Intelligent SLD and GIS webinars coming soon. Thank you all for taking this time to learn more about ETAP NetPM. Hope you have a great day.